Hello, this is Danica Dvorak, and Jordan Stevens is my partner for this project. He is not here currently. He's working on our paper for our project proposal, but this is a video explaining our project proposal for 460, our Monte Carlo class. So the overview of the project that we are proposing deals with pipeline incident data, from Alaska actually, and the data includes all of the pipeline incidences, spills, cracks, etc., and where they occur, so the distance from the start of the pipeline, and then what time, the date that incident occurred. And we want to predict when preventative maintenance should be done on the pipeline using that data, so that if we're only allowed to send out, say, like 10 preventative maintenance guys during the year, when and where should they go out to survey the pipeline? Because in our scenario, let's say if they're able to survey the correct range of pipeline at the correct time, then they would be able to prevent an incident, which would save the company money. And then to do this, we're doing a comparative study between different methods. These methods include the maximum likelihood, which is also known as the frequentist method, a regression analysis, and then Bayesian Markov chain Monte Carlo, otherwise known as Bayesian MCMC. A really quick literature review. These are some of our sources in APA formatting that we've done a little bit of a literature review on, and a lot of these use data to try and predict where pipeline incidences may occur or when they will occur, but none of them do that together, so that's kind of what's unique about this. Or they're doing specifically like when natural events happen, like how likely are pipeline incidences to occur. So there's that for our references. Our research question, the big research question that we'd like to answer is which of the three potential models above in the paper but below listed here will be most accurate in predicting the location and time of the next possible incident. And once again, those three models are the maximum likelihood, regression analysis, and Bayesian MCMC. So our hypothesis is that the Bayesian MCMC will be the most successful, and to create our Bayesian model, we're going to use the Weibull distribution. The method that we're going to use, so it's a comparative study once again, the biggest point that we want to drive home here is that once these models are created, which we'll be using MATLAB, we'll take 85% of the pipeline data, we'll randomly assign 85% of the data to be the training for all three models, and then the extra randomly assigned 15% of the data will be used for testing. So we'll randomly choose 15% of the data for testing and run it through each of the models and see which one is the most successful. And then we'll randomly, it's using the same data, but we'll randomly choose 15 other data points for testing and retrain each of those models with the leftover 85% and run it again. So we're going to run it through 5 times for each model and then compare the average prediction success of each model. So that is the method for how we are going about this. And then the business case, so like why this matters. There's currently over 2.1 million miles of gas distribution pipelines in the United States. A lot of that is in Alaska, which is where this pipeline data is coming from. And in 2017 alone, there were 17,745 pipeline incidences that were recorded. And the reason that this matters is like we want to avoid spills like the Gulf War spill in 1991 and the Gulf of Mexico spill in 2010 with BP. And we want to avoid spills like this for a couple of reasons. One, for environmental reasons, that's always good to avoid. But then also anytime that those types of spills happen, we see that those oil companies, those petroleum companies get massive fines. I believe BP got fined like $16-something billion, million dollars. And so that's not good for the company either. So if we can predict when this preventative maintenance should occur, it will be able to save companies lots and lots of money, which is always what business cases usually come down to. So I hope that made sense, hope that was informative for you guys, and that is what our project proposal is. Thanks for listening.